Students, today we are going to discuss about the vector algebra. It is particularly designed for BPC students. Generally they felt that they are somewhat a little bit of weak in mathematics, but actually it's not. They just scared about it. Here, if you understand the vectors in a right way, then it is easy to solve the problems in mechanics and as well as the electricity very easily. First of all, we have to understand what are the physical quantities. Then after, you will understand what is a vector or a scalar or a tensor is. Let's speak about the physical quantities. What is a physical quantity? Anything which can be measured is a physical quantity. In daily life, we come across with so many physical quantities, and we learn that physical quantities are of two types. One is the fundamental physical quantity and second is the derived physical quantity. If we see these physical quantities in broader view, we can classify the physical quantities into three types actually. One is the ratios. Second is the scalars, and finally the vectors. Physical quantities can be classified into three types. One is the ratios, the second is scalar, and third is the vector. First we go with the ratio. Here in physics we come across with so many ratios. Such ratios are, one is, which is very important one, is refractive index. I think you are getting now. The second, that is quotient of friction. The third one, any angle, and the fourth one is the numbers. Okay, these physical quantities doesn't have any units actually, but this angle we will measure in radian and steradian. We'll talk about it later. The second one is a scalar. Here you have to understand what is a scalar is. First I am taking a example of mass. Mass is said to be a scalar. Mass is said to be a scalar. Mass has the magnitude, means measured value. If you go to the shop, you will ask, give me 1 kilogram of sugar. Okay. And again we added 1 more kilogram, then it turns to be 1 plus 1 is equal to 2 kg. 2 kg is the magnitude of the sugar. It is the magnitude of the mass. Okay, if you watch it, it doesn't have any direction. Okay, the physical quantities which are having the magnitude without direction is a scalar. And if you go with the kinematics, there you will find one more physical quantity is there. We call it as the distance. Distance is a scalar. Distance is a scalar. And similarly, if you go with the speed, speed is another scalar, and work, it is one more scalar. What we'll understand now from all these things? Any physical quantity is said to be a scalar when it has only the magnitude, means measured value. Maybe now you are getting a doubt about the time. Time, is it a vector or a scalar? Obviously, time is a scalar. And we come across with so many physical quantities. Maybe it has a direction. Why did I say time is a scalar? Even though it has a direction. It started from past, entered into the present, and it will enter into the future. It has a particular direction, even though it is not said as a vector, because any physical quantity which has a unique direction is a scalar. It goes with the electricity also. When you are reading about the electricity, we learn that what rate of flow of the charges, the motion of the charges in a particular direction. It has a direction, but it is not a vector. Charges have the what? The fourth one, fifth one, charge. Generally, charges are available of two types. One is the positive and second is the negative. Though they have the positive and negative signs, don't mistook that. The positive and negative signs give the direction. If you take the Cartesian coordinate system, you will find the plus and minus. Don't mistook with that. Charge is a scalar, and electric current also scalar, even though it has a direction. Okay, and pressure also a scalar. Pressure is force acting on unit area normally. The direction is normal, even though it is a scalar. Then what is a vector? You have to understand now. What is a vector quantity? A physical quantity which has both magnitude and direction. It's not completed now. A physical quantity which has both magnitude and direction, and it has to obey the triangular law of vector addition. It has to obey the triangular law of vector addition. Then only it is said to be a vector. What is a vector? A physical quantity which has both magnitude and direction, has to obey the triangular law of vector addition. Additional to that, it has to follow the commutative property. Okay, here now we are learning what is the vector is. But I told you, vector means what? Vector is a physical quantity. It has the four characteristics actually. The first character we are writing here. It must have magnitude. What is the magnitude? Magnitude means the measured value. Magnitude means measured value. And the second one, it must have the direction. The third one, it has to obey the triangular law of vector addition. Okay, or it has to follow the parallelogram law of vector addition. And the fourth one, it has to obey the commutative law. That means what? A plus B must be equal to B plus A. Okay, these are the four characteristics of a vector. What is that? First of all, it has the magnitude. The second, it must have the direction. Third, it has to follow the triangular law of vector addition or parallelogram law of vector addition. You are aware of that. So many times you wrote the equation which goes with the parallelogram. That is what r square is equal to p square plus q square plus 2pq cos theta. R square is equal to p square plus p square plus q square plus 2pq cos theta, or the resultant r is equal to under root of p square plus q square plus 2pq cos theta is the parallelogram law of vector addition. And what is the commutative law? 2 plus 3 is equal to 3 plus 2. It has to obey that. Here these are the main characteristics of a vector. I repeat it again. It must have the magnitude, means what? Measured value, and direction. It has to obey the triangular law of vector addition and as well as the commutative law. Now we learn the representation of a vector. How a vector is represented. Generally, if you take any physical quantity, a vector is represented like this. If you say A is the physical quantity, okay, write A and keep a arrowhead on. It is the representation of a vector. You have to keep a arrowhead. Or in some books, this A is written with bold letter. That means what? Thick. If anything is represented with a thick letter, it is the vector. Generally, in foreign books, we will get such kind of print. Here, I said a vector is represented like this. And if you take a physical quantity A, let is the force. If you want to write the force is a vector. I have to put a bar on. And what does it mean? What is the meaning of the bar? Here, see, I took an arrow. It is the tip of the arrow, isn't it? Is the tip, and it is the tail of arrow. Okay. Say the tip is A and tail is B, and this vector is represented as AB bar also. AB bar also. Okay. And what does it mean? This arrowhead, this one represents the direction of vector. The arrow represents the direction of the vector. And see, the length between the two ends, this is the length, bezier length between the 2 points. This represents the magnitude. Understanding me? This length represents the magnitude. This one, the arrowhead represents the direction of the vector. Okay. Then the length between head to tail represents the magnitude of a vector. Understanding me? Okay. Here, for example, 4 lines are drawn like this. The first line, it is representing a vector, as the second, and is the third, and we have fourth. Let's say it is A bar, it is B bar, and it is C bar, and it is the D bar. The direction of four vectors is same, but their magnitudes are different. The direction is same and magnitude is different. Okay. After representing a vector, then after we have to learn how vectors can be added. Briefly I will explain, later you will understand the laws of vector addition. Here, for example, you say it's a vector A bar, and we have one more vector, say it's the B bar. We have to add these two vectors. How can we add? We have the two methods to add these two. One such method is tail to tail. Tail to tail method, and the second one is head to tail. Okay, and you know that it is the head and it's the tail, and it is the head and it's the tail. First, what I have to do, I have to transpose the vector. See, here you understand what is the transposition of the vector, transposing of the vector. Take this vector, okay, we have to move this vector from one place to another. Okay, we can move this vector like this without changing any direction, is known as transposing of the vector. It is tail, okay. The same thing has happened. It moved from position A to position B. All the parameters remains constant. We call it as the transposition of the vector. Okay, and it can also be moved. It can be moved from here to here. See what I am doing. I am moving this vector from here to here. I move this. Is the vector A. It has been transposed from A to B. Okay, it is head is added with the tail of the vector B. Okay, here vector A's head is added with the tail of the vector B. Okay, it is the one method I showed here, head to tail, head to tail is one such method. In this way you can add the two vectors, and the second way tail to tail. It is simple. I am transposing this vector from here to here. Okay, it is transferred from here to here. I am redrawing the same here. It is the head and is the tail. I am transposing. I am moving this, and I kept here. Okay, is the tail and is the head. See this, tail to tail. Vectors can be added by two ways. One is head to tail and second is tail to head. And you learn about what is the transposing of the vector. Moving a vector from one place to another place without changing its magnitude and direction is known as transposing of vector. Then after, we have to understand what is the meaning of the vector, what is that angle between the two vectors. We are learning about the angle between the vectors. I hope you understood how vectors can be added. They can be added tail to tail and as well as the head to head. See, is the first vector and it is second vector. Let's say it is A bar and it is the B bar, and these are the heads, and these are the tails. Tail to tail we added. The second one, what we did, it is the second vector, it is b bar, and I transposed this vector to here. Then what happened? It is head, is the tail, it is the head, and is the tail. Okay? If you watch it carefully, you will come to one more conclusion. Already I told you, we have to find the angle between the vectors. Angle between okay, I am taking the same thing. When I transport the two vectors, okay, it is a bar and b bar. I'm just extending this. Okay, this represents the angle between the two vectors. Okay, this represents the angle between the two vectors. It can be, that means what, smallest angle. If you go further, is a larger angle, and I will show here. The same thing I am drawing here. Okay, I said is the A vector and it is the B vector. But head to tail arrangement. Here it is the angle between the two vectors, theta of AB, but it's not. Okay, here it looks like that it is the angle between the two vectors. It is not, but it is. It's the angle. Means what? When we are adding the two vectors, always we have to take the smaller angle. Okay? It is about the vector representation. What is a vector? I already told you. A physical quantity which has both magnitude and direction, and it has to obey the triangular law of vector addition or parallelogram law of vector addition. Additional to that, it has to follow the commutative property. And what is the scalar is? Scalar is a physical quantity which has only magnitude without direction. I mentioned the two physical quantities when I am explaining about the scalars. I said the charges, pressure, and as well as the electric current have the magnitudes and directions, even though they are not said as the vector. That means what? Any physical quantity which has unique direction is not at all a vector but is a scalar. And I already told you, ratios they do not call as the vector or the scalar. Okay, the best example for that is refractive index, quotient of friction. Numbers, they are not at all. The vectors are the scalars. I hope you understood the class well. In next segment, we are going to learn about the types of vectors. Additional to that, we will learn the parallelogram law of vector addition. Thank you for watching my video.